Ladies and gentlemen, welcome to day one of AWS Reinforce. Hopefully, all of you were excited to see CJ's keynote today, of which a couple of the services here that we'll talk about in our session were featured. So, exciting stuff. Well, today we're going to cover how Fannie Mae and FINRA have architected for data resilience on AWS. My name is Nancy Wang. I'm the Director and General Manager for AWS Data Protection, joined here with Matthew Mariello and John Simon as our customer speakers, as well as Pollock Desai, who's our Head of Product for Data Protection. A couple things that we'll cover during the session today, starting with how do organizations today build resilient applications on AWS? Then we'll turn it over to Matthew and John to talk about how they're putting all of these principles into practice today. And then finally, we'll recap and open it up to you all for any questions. So here's what you can take away from today's talk. Customers want simple, fully managed services that protect their data in the cloud. They're also focusing on application data resiliency and ensuring that they have business continuity. So today, we're going to talk about what data resiliency is, why it matters, and how you can incorporate it into your architectures. Of course, data resiliency is a pretty broad topic, and if we were to cover all of the tools that AWS has in its toolbox, we'd probably run out of time and not give enough stage time to our customer speakers. So instead, today will be a high-level overview of common data resiliency design patterns that we have seen our customers put into practice. And of course, these terms we've heard pretty interchangeably, like data resiliency, high availability, data protection. So let's talk about what they mean and how you all can apply these concepts in your environments. So let's talk about data resiliency. It's the ability of your applications to withstand partial and intermittent failures across different components and to also recover from unexpected conditions. What customers expect today is that applications and services are always on and reliable, that they are highly available. What they don't want to think about are hardware failures and routine software updates, unless, of course, you skip them and a hacker exfiltrates your personal information. All customers also don't want to remember that it's Black Friday and that your site is getting 1,000 times its normal traffic. Net, customers expect 24/7 resiliency. Of course, this creates a need for highly distributed and sophisticated system architectures that are supported by distributed teams who have multidimensional skills. High availability is about preventing loss of service. It's dealing with smaller scale but more frequent events like component failures, network issues, and load spikes. And sometimes it's about the graceful degradation of your service instead of hard failures. One example would be video conferencing, which is something that we do a lot every single day. If the internet's having a bad day, rather than failing to stream video, you'll see the video quality degrade, lower bit rate, lower resolution. In severe cases, your video might stop altogether and drop to audio only. Of course, that's not ideal, but the meeting can still continue as opposed to it just crashing altogether. So even better, of course, when the video quality dynamically improves as your network issues are being resolved. One of the tenets of good application design that we practice here at AWS is to design for failure. And so as our CTO, Werner Vogel, says, everything fails all the time. So what does that mean? For resilient applications, we need to provide continuous service, disrupt anything, despite anything that could happen, like disruptions. The other side of data resiliency is disaster recovery. Any event that keeps your application from fulfilling its business objectives is considered a disaster. This includes natural disasters like earthquakes and hurricanes, technical failures like site-wide power outages or loss of network connectivity, and of course, human actions like inadvertent misconfigurations or unauthorized outside party access or modifications. And within disaster recovery itself, there are two measures that we often talk about. One is how long does it take to become operational again? And that is commonly known as RTO, or the recovery time objective. Number 2, how much data can we afford to lose? That's known as our RPO, or recovery point objective. And so therefore, if I'm backing up my databases every hour and I lose all of my database servers, then I can lose at most 1 hour's worth of changes. Therefore, my RPO is 1 hour. Likewise, if it takes me 4 hours to provision new database servers and restore the data from my database backups, then my RTO is 4 hours. Beyond customer expectations, there's also massive business impact. And for that, I'd love to invite my colleague, Palak Desai, to talk about the business impact of data resiliency.
Thank you, Nancy. I'm Palak Desai. I'm the head of product for AWS Data Protection. And in my role, I speak with customers all day long, and they tell me the impact in terms of dollars and in terms of reputation that they have to experience when they do not have a proper data resiliency posture for their applications. According to research done by IDC, just in 2020, there was a loss of around $1.25 to $2.5 billion around data resiliency and lack of data resiliency for the applications. Now, on the flip side, if you have taken care of your data resiliency posture for your applications, according to BCG, the cost savings were between 15 to 25%. So this also gives you peace of mind in terms of business continuity as you think through your data resiliency posture for your applications. Now, what is the impact versus likelihood of failure? Majority of the failures happen due to human errors. Say, for example, you rebooted the wrong server and your application went down. You had a software upgrade, which was not the best software that you wanted to upgrade to, and your application went down. Or there was a misconfiguration. The impact of those can be reduced through automation. But whenever something like this happens, high availability can help quite a bit because you have a secondary copy of your application that can take over and can service the needs of your business. Then there are certain other issues, such as, say, July 4th is coming up, and there will be lots and lots of sales, and people will be shopping. So your site may experience high load, and your servers may go down because of that high load, because of, say, for example, they're experiencing 95% peak load, and the servers cannot take it. Again, in such a case, designing for high availability can help because a secondary copy of your application can service the needs of your business. And then there are rare situations such as the entire region is brought down because, say, for example, there was an earthquake or there was flooding, and as a result, your entire data center went down. In such a case, you do have to plan for disaster recovery, right? Because your entire data center is down, your applications are down, and you have to kick into a mode of disaster recovery. Now, often customers ask me, how should I think about high availability and disaster recovery? And the answer is, it depends on the criticality of your application. Now, as an example, if you're running a test workload, and it can fail, in such a case, you want to think through high availability because you're not missing out business critical information if the test workload goes down. There is loss of productivity, but not loss of business critical information. But in a situation where you're running, say, for example, you're in airlines and you're running a scheduling system, an app that schedules the flights, in such a case, you do want to think through disaster recovery because that is mission critical to your business. Now, at AWS, we have a shared responsibility model between our customers and ourselves. What I mean by that is AWS is responsible for data resiliency and resiliency of all in-cloud AWS services. What I mean by that is AWS is responsible for the hardware on which the AWS services run. It's responsible for the network, the compute, the storage, the database, and the facilities that host AWS cloud services. The customer, on the other hand, is responsible for applications they run on top of this infrastructure. They are responsible for upgrades, security patching of your guest OS. They are also responsible for making sure that you have configured appropriate firewall rules through the AWS security groups. Moreover, the customer is also responsible in creating data resiliency posture for the applications through a variety of capabilities that we expose, such as replication, snapshotting, backup plan management, and monitoring. One key architectural principle of data resiliency is the fact that there should be no single point of failure. This is true even for the infrastructure on which AWS Cloud Services runs. As a result, AWS runs in 30 regions worldwide. And each region has multiple availability zones. The AZs are independent of one another from a viewpoint of fault. What I mean by that is a fault in one AZ does not affect another AZ. We have 96 availability zones worldwide that customers can leverage to create resilient applications. The AZ level independence helps our storage services, regional storage services, such that a fault in one AZ does not bring down or affect data services running in another AZ. S3, DynamoDB, and Elastic File Systems leverages this AZ level independence to provide data resiliency and 11 nines of durability. Our customers can also use the AZ level concept to ensure there is high availability, because a fault in one AZ does not affect applications running in another AZ. Moreover, customers can also leverage AZ level independence to increase and improve their compliance and data sovereignty. AWS has the most comprehensive set of storage services. We support block, object, and file systems today, and we have capabilities to improve the posture, the resiliency posture of your applications utilizing those services. When you think about data resiliency, the first thing that you want to start off with is think through your RTO, RPO, as Nancy mentioned. What is your recovery time objective, and what is your recovery point objective? How quickly do you want to recover your applications, and what is the loss that you can withstand? Once you do that, you have a slew of inbuilt capabilities such as point-in-time snapshots, versioning, replication, elastic disaster recovery that you can utilize to ensure there is resiliency in your architecture. If you have more than one service that you are trying to protect and make it resilient, you can always use AWS Backup that provides you a consistent policy framework to be able to manage backups for your data and make them resilient. AWS Backup also provides write once and read many times capabilities and data immutability. These are the tool sets that AWS provides to our customers to incorporate in their architectures to make the applications resilient. Moreover, if you have a certain third-party vendors that you want to run with, then AWS also provides a set of data protection partners you can choose for your data resiliency posture. The last important thing around data resiliency is the fact that you should keep on testing your posture on an ongoing basis. So test through your recovery mechanisms so that you can be assured that when there is a disaster, you're protected. Since RTO and RPO is the key mechanism for defining your data resiliency posture, I would like for Nancy to walk us through different scenarios that customers can think through and inculcate in their architecture around RTO and RPO. Nancy?
Sounds good. Thank you so much, Palak. And as we heard from Palak, there's a whole slew of native AWS services, capabilities, and managed services like AWS Backup and Elastic Disaster Recovery that can help you throughout this continuum. So let's unpack that and talk about what disaster recovery strategies you can implement in your environment. So to start off with the broad overview, they can be generally categorized into 4 approaches, each with a different balance between cost, implementation, operational complexity, protection, and of course, recovery time. So let's start with backup and restore, all the way on the left-hand side. That's for low-cost protection of your data. However, in the event of a disaster, it could be hours or even days in order to restore your data, re-provision your applications, and get your application back online. And so for your non-critical applications, backup and restore might be the right strategy for you. Next, I'm going to skip Pilot Light for just a second and come back to it a little bit later. Now, on the third category, we have warm standby. And that's pretty similar to your traditional on-premises DR. You have a secondary copy of your application stack provisioned in a separate location that is typically in passive mode. Data is being replicated from the active site to the passive site periodically or even continuously based on the RTO or RPO, that you've set. The standby site is always running, but not fully scaled up so that it's cheaper to operate. And of course, in the event of a disaster, you can fail over, scale up, and make your warm standby the active instance. Warm standby, therefore, is a good balance between minimal recovery time for your business critical applications and also cost. Let's come back to Pilot Lite now. Pilot Lite, then, is essentially a cost-optimized version of warm standby, and it's something that is really unique to the cloud. In Pilot Lite, data is still being replicated depending on your RPO, just like it is for warm standby. However, the key difference is that your second site is only partially provisioned. So before you can fail over completely, you need to provision some AWS resources, then scale up. Recovery time, then, is also about tens of minutes versus just minutes for warm standby, but it also comes at a significant cost savings. And finally, for mission-critical services that really can't afford any downtime, you could employ a multi-site active-active strategy. Your application would be running live in multiple regions, and traffic's directed to them based on load and also latency. And so if there's a disaster and one site goes offline, the other site can dynamically scale up to absorb the additional load, but there is no interruption to your business. So ultimately, which disaster recovery strategy you use can be based on your business continuity requirements and also your regulatory and governance requirements. So let's bring it all together. We have discussed the AWS well-architected framework to learn, measure, and also improve the resiliency of your workloads across each of these 5 pillars. So let's start with operational excellence. That's the culture that we have built at Amazon for our own infrastructure. Then let's move on to security, which you've often heard our CEO, Andy Jassy, talk about is job zero at AWS, and it's a principle that we've baked into all of our products and mechanisms. Then, talking about reliability, we've covered a lot of that today during the presentation, including high availability as well as disaster recovery strategies. Then, of course, performance, which is not just about being the fastest, but having the performance to meet your business needs, and also how to achieve that efficiently with AWS. And finally, the cost optimization pillar, which is not just about being the cheapest, but also getting value for what you're spending. To summarize, if you incorporate all of these 5 pillars into your architectural design, it'll help you produce stable and efficient systems, which allows you to focus on your business and functional requirements. With that said, I'd love to turn it over to our customer speakers to go through their use cases and also their environments. Matthew, over to you.
Thank you so much. Hi, everyone. My name is Matthew Moriello. I am the Principal Cloud Architect at FINRA. I want to take a few minutes to talk to you about how we approach resiliency and protecting our data so we can have it available to applications and support what we do. But first, let me talk about what we do. In a nutshell, investor protection, market integrity. It's our goal to make sure that the markets are fair and safe places for everyone involved. We do this by writing rules, examining investors, doing analysis on data and actions in the markets, and actually enforcing and penalizing people who misbehave and do things they shouldn't. We do this with sort of a 2-pronged approach. The first part is the Consolidated Audit Trail, something that we've worked on with the Securities and Exchange Commission for a number of years, and it is essentially the big database of everything that happens in the markets. Every night we collect information from all the exchanges, all the brokers, dealers who trade on those exchanges, and we stitch it together into a big database and have it ready for everyone the next day. It's not only for us, but it's also for all the exchanges. They use this to do their own enforcement activities as well. But then the other half of it is FINRA, the regulator, the side of the business that goes, looks at that data, analyzes it, looks for patterns of bad behavior that we already know, as well as looking for new patterns of behavior that we need to start looking for in the future. As you imagine, this is large. We use a lot of Amazon services to manage this data and to analyze it, do the work. So in numbers real quick, every night we'll get several hundred billion records from these exchanges, and we'll run several 100,000 nodes of compute every evening, every day to get through this, to do the stitching of the database, to do the actual analysis of the data in order to do that mission. We're well over half an exabyte, and we expect to probably reach that in the next year or two, maybe sooner if things keep growing the way they do. So it goes without saying, data is important. You want to protect it, but why is it important to us? As I mentioned, we will use this for actual enforcement. We will suspend people and actually expel people from the industry. We can levy fines, and we can actually move criminal activity. We can go to courts and actually get people in trouble. So if we're doing that, like, our data needs to be authentic, reliable, like provably so. So protecting that data is important. Not only protecting it, but actually being able to trace it. One of the things that we do in our data catalog is track the lineage of all data. Data comes in, there's a record, and then every derivation of that data has a where did this come from, where did this go, who operated on it, and when, so that we have a full chain of custody to prove the authenticity of this data as we go forward with actual enforcement activity. So our footprint in Amazon isn't terribly surprising. Naturally, we have a massive data lake, largely comprised of S3, but lots of applications that sort of interact with this data, producing data, consuming data. Each of these applications are fairly well siloed. They've got their own encryption boundaries, their own little scratch databases, whatever they need to do their work. But the data lake itself has its own separate encryption boundary, manage those keys differently to do the appropriate amount of sharing while still protecting the data. So let's get into that data lake. S3, this shouldn't surprise anyone. We run out of US East 1, Virginia. That's our primary site. The first and most simple things is objects are versioned. We don't allow deletes on the objects. We use lifecycle policies and appropriate approval mechanisms to manage our object retention schedules, but no one gets to go in and start deleting data. That's just not how it works. And when we started this journey, the resiliency afforded to us by multiple availability zones in a given region satisfied our needs to tolerate sort of physical failures of data centers. But we still had to protect the data. So the first thing we did was, when we actually started building this all out, we would archive data. We would send it to another account in another region, straight into Glacier, now deep archive, and it goes away. The access to that account is incredibly limited, but it's that cold storage we need in the event of a catastrophic failure or some other event, right? If an admin pushes the wrong button, which should never happen, or malicious activity, ransomware attacks, data just being deleted, unfortunately. That's how we get that back. Now, at some point, that wasn't good enough anymore. So we started building out our EDR, our Enterprise Disaster Recovery, so that we could have a better ability to operate in another region in the case of region failures or something else that we can't really plan for. So we'd actually worked with the S3 team quite a bit in order to get them to roll out along with us this ability to do multiple targets for S3 replication. If you remember, that came out a few years ago. We had a hand in that, and it served us really well. So we've started to replicate not just to the archive, but to another set of buckets in another region. These are all part of our primary production account, so they're still visible. We replicate the data to live storage classes. But that means that we can now have applications actually run in those regions, operate against that data, and use it. Now, it shouldn't surprise anyone, this can be really expensive. Fortunately, a lot of our data is time series data, and we can operate on, say, the last 3 months and still do 90–95% of our work. So we do roll data off those buckets after about 3 months, depending on the needs, and that helps us manage the cost, yet still have a data lake that can operate in another region and solve most of our problems. When we did that, we made sure to use replication time control, the feature that helps to ensure short SLA for all the data replication and lag. So we actually maintain an incredibly small RPO, and the RTO isn't even a discussion because the bucket's live. It's already in hot storage and ready to go. And That's pretty cool if you're a nerd like me. So when all that's put together, we essentially end up with a multi-region data lake where we can serve requests out of any region that we need to run in, while also having cold storage to claw data back in the event of something terrible or unplanned happening. But naturally, S3 is not the only place we keep data. We are a heavy user of RDS. We have hundreds of databases across our accounts and environments, and that data needs protected too. When we started doing this, there weren't services like AWS Backup, so if you wanted to do anything multi-region, you kind of had to roll it yourself, and we did. I've worked on them myself, the scripts that we run that look for new snapshots created every day and copy those over to other regions. Again, for the same reason we did the archive with S3, we keep our data protected against hardware failure in a region, against deletions by tucking it away in a safe place. But when we have S3 with almost no RTO or RPO, that doesn't keep up very well. So when we were doing this EDR rollout, we also made a point to really adopt global clusters within Aurora. This allowed us to have databases that would replicate to another region in almost no lag, and that would keep up with the replication that we had with S3. Another really nice thing about Aurora is because the replication's happening in the data plane, we don't need to run instances. We can actually run these headless clusters in Ohio, replicating data with almost no replication lag, and not pay for the compute to do it, which really helps us maintain, costs, keep that under control. So again, we've reduced our RTO from what could have been 24 hours, or RPO, forgive me, from what could have been up to 24 hours for a snapshot to seconds. And again, we put this all together. We've got multi-region databases that I can go and run off in any region with very little time to be operational. I still have my snapshots being copied across regions, and that helps me get data back in the event of loss or manipulation. So we've got data in multiple regions, but that's only so good if you can't do anything with it. So like many organizations, we do drills where we test our posture. Can we run our applications? Do they succeed? And one of the things that we have all of our application teams do when they deploy, they also deploy what we call their canaries. They put out a set of Lambda functions that are designed to test their application fairly deep through, as well as all their dependencies. All these Lambda functions will then report back to our bird cage, which is kind of what you would expect, the big heat map of reds and greens, letting us know what applications are healthy and what's not. And it's a really great way to have a health dashboard of everything you're doing with the test. So when everything's green, you know you've got success. Now, I talked about us using home-rolled scripts for RDS because that's what we needed to do at the time, but we're actually in the process of rolling out AWS Backup to help us get better management of our snapshots as we copy and move them around across regions and the retention of them. One of the issues we ran into with AWS Backup, if you remember early on, I said every application's got its own KMS key, and we need to preserve that down to the RDS instances and to the copies that they're going to be moving across regions. And if you work with AWS Backup and you're familiar with it, you know that means that you will need a vault for every KMS key and backup plans for KMS keys, which can be pretty unwieldy. So we adopted a strategy that we've used in a couple other cases where we want to have some control over what people can do, but we can't really meet that with IAM policy. And we use Lambda functions, essentially functions that teams can call during their deployments, and it will do the work for them based on a set of inputs. This allows their deployment pipelines to simply say, I need my backup, please, and the things will go in place to meet the minimum expectations for the enterprise, but also gives them the ability to make a call, says, you know what, I need a custom one. I need this thing to stay longer. I need more frequent backups here, and this will give them that opportunity. So by adopting the AWS services, we know that we'll be better able to keep up with other things that they introduce that this backup solution can support. So in a nutshell, that's what we do. Now I'd like to hand it over.
Thanks. Good afternoon, everyone. I'm John Simon. I'm the fellow for public cloud at Fannie Mae. For those of you who aren't familiar with Fannie Mae, we support the secondary mortgage market in the United States. That means we don't originate loans, but we purchase those loans and create mortgage-related securities to create liquidity. We're one of the key contributors to the 30-year fixed-rate mortgage. In the United States, 65% of the population, there's 65% home ownership in the United States. That means 2/3 of the occupied homes are owner-occupied. Fannie Mae and the liquidity they provide is one of the core reasons that occurs. In 2020, Fannie Mae provided $1.4 trillion of liquidity to the market, which means Fannie Mae helped finance 1 in 4 homes in the United States. We started our AWS journey in 2015. At that point, it was a greenfield effort, and we decided we wanted to make sure security, resiliency, and automation were core to everything we were doing. Automation kind of speaks for itself. Automation is basically software or infrastructure as code, continuous CI/CD, auto-scaling, et cetera. Security, well, we basically let our InfoSec team implement their entire wish list. So we've got lifecycle segmentation, microsegmentation, network segmentation, data contracts between applications so we can keep track of interactions. Resiliency, on the other hand, is a little more nuanced. Resiliency requires you to know who's doing what, where, and when. So to that end, we mapped our application, our apps and data to business processes to better understand criticality and priority. And we then analyzed Amazon services to assess the RPO and RTO they could provide. We then took those two things and were able to develop reusable technical patterns to meet our business needs. We then brought all that together to create application deployments in region and cross region that would keep our business moving. So to break that down, we require all applications to deploy across multiple availability zones, and we require all higher environments to be deployed across regions. Now, that doesn't preclude lower environments from deploying across regions. We do let them test it. We just don't require them to do that. And even in development, we'll let applications not deploy over multiple availability zones so they can test. But outside of development, everything actually has to be through a pipeline, so they couldn't do that manually without getting flagged in test or higher. So we verify all those deployments, as I said, in CI/CD, and we also have ongoing monitoring. Any deviations from that are flagged, tickets are generated, and app owners are held accountable. We replicate all our critical business data cross-region using AWS services that we've designated appropriate for that RPO and RTO. So for example, we've got RDS Global DB and S3 CRR RTC when we need effectively near instantaneous replication. As for failover, we went ahead and created our own automation framework. And the reason we did that is we wanted to make sure our failover framework, our failovers, were independent of CI/CD, and they were able to compensate for AWS regional control plane limitations. So we built that from the ground up using step functions and Lambda. That all sounds great. That was 8 years of effort to achieve all that. It works well, but there's always things we can do to enhance what we've designed. So we asked ourselves, how could we further protect our environment and prepare for the unforeseen? One thing that every business continuity framework could use is a source of truth for data that we can go back to, something that's immune to corruption or tampering that we know will always be pristine. So that's where immutable backups come out. What's an immutable backup? An immutable backup is basically file, data, object that can't be modified in any form or fashion. So it's sort of like Worm, but it has a retention period. So you're not just writing it once and reading it many. You set a retention period, and during that retention period, it can't be modified. AWS Backup Vault Lock provides that as an optional feature on AWS Backup Vault. It basically permits in compliance mode, when that's enabled and the warm-off period is expired, anything you put in that vault is going to be immutable for the duration of that retention period. So you can't change it, Amazon can't change it, root for the account can't change it. An S3 object lock in compliance mode works exactly the same way. And I found that out the hard way. I've actually got a file I should be able to delete sometime later this year, in December, I think. So I need to give you a little background on how we deploy Amazon so this makes a little more sense. In order for us to provide self-service in our multi-tenant accounts, we use programmatically generated IAM policy along with roles that are authenticated through a central service. All user access is via entitlements that are aligned to those IAM roles, and we construct that IAM policy centered around two core concepts. The first is obviously least privilege, like everyone does, but we have a unique application name that we call application short name, and we use that programmatically generated policy in conjunction with tags to provide the absolute minimum required so applications can only interact with their resources in that specific account. So when we deploy an application, we deploy several foundational services. Along with that policy, which is a foundational resource, the other foundational resources are going to be a backup vault. We deploy a backup vault by application along with a backup plan, and that backup vault is encrypted with KMS. The policy that goes along with that backup vault backs up all the data resources the applications would use, whether that's going to be EBS, RDS, FSX, Dynamo, whatever. They all get backed up to that vault, and there's an immutable policy that's assigned to that meets our requirements. All of the user access, all the automation, that all gets logged to CloudTrail and then goes into our corporate SIM so we can do reporting. In addition to all those governance, and in addition to what we've done there with IAM, we've got additional governance and safeguards on top of that. We've got SCP at our org level that limits who can modify vaults, policy, or tags. We monitor CloudTrail and alert on any attempts for anyone to modify any of those. We also monitor to make sure we've got successful backups and we've got all the number of backups we'd expect to have based on a retention policy. And then we also monitor anyone who's possibly modifying tags, since that's core to what we're doing with our IAM policy. As for vaults, vaults can only be deleted if they're empty. If a vault was ever empty in our environment, that would generate a very big red flag. The only time that would ever occur would be if we were retiring an application. We also perform random restores of applications on a regular basis to make sure the data we've actually backed up is functional. This is one other little tidbit. This actually helped us. What we ended up doing was leveraging S3 in object lock, S3 object lock in compliance mode along with net backup. Net backup apparently supports S3 as a storage location in the same way it would support tape, disk, or NAS, and it has direct integration with object and compliance mode. Object lock in compliance mode. So this lets our backup team have a single pane of glass for on-premises backups to achieve immutability. So that's all I have. Appreciate it. Thank you.